Hello, in today's lesson we are going to take a look at the API gateway component of the WSO2 API manager. To introduce the API gateway, it mainly consists of the same Synapse runtime that is part of the WSO2 ESP. So the API manager product simply reuses that same runtime as the API gateway, and it is responsible for hosting all the API proxies that are created in API manager. So the main thing that the API gateway does is it secures, protects, manages, publishes usage stats, and helps to scale API calls. So if we take a closer look at how the API gateway functions from the point of an API invocation, the first thing that the API gateway does is it will intercept the actual API invocation that it receives, and it will try to map that invocation with API proxy and resource that is already running on that API gateway. So if the API gateway is able to find a matching API proxy and resource, the next thing it does is it needs to authorize this API call to make sure that it is a valid one. And to do this, the API gateway will extract the access token that is sent along with the API invocation, and it will send this to the key manager component of the API manager. And the key manager component will validate the access token against the database and return back to the API gateway, informing it if the API call is valid or not. So provided that the API call is deemed to be valid, the next thing that the API gateway does is it will publish API invocation data to the traffic manager. So the traffic manager is responsible for enforcing throttling policies for the API proxies that are created by WSO2 API manager. So what the API gateway does is it will publish this information to the traffic manager asynchronously, and then the traffic manager will keep a track of the number of calls that the API that a given API receives, and will decide if that API has exceeded the given throttling policy that has been configured for that particular API. And then it will inform the API gateway if that event occurs, and then the API gateway will then stop processing API invocations for that given API until the time window of that of when that throttling policy needs to be enforced for expires. So given that the API call does not trip the throttling policy, the next step that the API gateway will perform is it will actually execute any custom mediation extensions that have been configured for that given API proxy. And then if API statistics have been enabled, the API gateway will publish stats events to the analytics server for later analysis. And finally then the actual invocation call will be forwarded to the API backend. So as you can see, because the API gateway does all these actions, it needs to make sure that it is fairly fast, so that it does not add too much of high latency to the actual API invocation. So to do this, the API gateway does a few things to improve its performance. So the first thing that we can look at is the actual API call authorization. So as I mentioned before, the key manager is responsible for checking the access token that is sent in the API invocation against the data that is in the database to see if it is valid, and then it will respond to the gateway. And so once the gateway receives this validation information, it can actually cache this information. And so there are two options for caching this information. One option is caching the information at the gateway level itself, and the other option is caching the information at the key manager. So if we look at the option of caching at the gateway, what will happen then is that subsequent validation requests that arrive at the gateway can be validated against this cache. And this means that the gateway does not need to consult the key manager component in order to validate the access token. And if we take a look at the option of using the cache at the key manager level, the validation will be done by the key manager against the cache instead of going to the database. So if we compare these two methods, using the gateway cache is more performant because it prevents the need for having to go to the key manager node, which is a separate network hop, if the product is set up in a distributed configuration. But if the gateway component is actually deployed in the demilitarized zone of your network, you may choose to not want to have information such as key validation information in memory of the gateway, which might be deemed as a security risk. So to cater to that requirement, you can choose to have the cache in the key manager, which provides some kind of performance boost because you do not have to actually, it does not have to query the database. By default, with the product, it is the gateway cache that is enabled. As a side note, I'd also like to mention that all these caches have a limited timeout. So the default timeout that is set for these caches is 15 minutes. And after the 15-minute time interval exceeds, the caches get cleared. So the next thing that the API gateway does is it caches information regarding resources. So if you take API resources, there are certain information such as the authorization type and throttling level that are defined for API resources. And these are usually properties and that reside in the database. So by caching these properties as well, it prevents having to always go to the database to retrieve these particular properties. So this also improves performance. So if you look at the next point, which is response caching. So response caching is an optional performance improvement that you can choose to enable, and it uses the ESB's cache mediator to be implemented. And what it does is it will actually cache responses that are actually received for a given API resource. And so it will actually eliminate the need to constantly go to the backend to fetch responses. So this actually ends up reducing the load on your backend. So to eliminate the risk of actually serving stale data from the cache, from the response cache, you can choose the actual timeout value that cache will have. So this will ensure that whatever data that is served from the response cache will only be available for the time that you stipulate. And if any data does get updated once that cache does expire, you can the API gateway will fetch the latest updated data from your backend, and this can all be configured in the publisher UI when creating an API. So that concludes the look that we had today about the API gateway. Thank you.